Welcome back. In this lesson offered by Simplilearn, you'll learn how to visualize large data in Python using Matplotlib. In this lesson, you'll learn to explain what data visualization is and its importance in today's world. You'll understand why Python is considered one of the best data visualization tools. You'll also learn in detail about Matplotlib and its data visualization features in Python. In addition, you'll learn to list the steps involved in creating types of plots. Let's now start this lesson by defining what data visualization is. Data visualization is the technique to present the data in a pictorial or graphical format. It enables stakeholders and decision makers to analyze data visually. The data in graphical format allows them to identify new trends and patterns easily. Well, you might think, why data visualization is important? Let's explain with an example. You are a sales manager in a leading global organization. The organization plans to study the sales details of each product across all regions and countries. This is to identify the product which has the highest sales in a particular region and up the production. This research will enable the organization to increase the manufacturing of that product in the particular region. The data involved for this research might be huge and complex. The research on this large numeric data is difficult and time-consuming when it is performed manually. When this numeric data is plotted on a graph or converted to charts, it's easy to identify the patterns and predict the result accurately. The main benefits of data visualization are as follows. It simplifies the complex quantitative information. It helps analyze and explore big data easily. It identifies the areas that need attention or improvement. It identifies the relationship between data points and variables. It explores new patterns and reveals hidden patterns in the data. There are three major considerations for data visualization. They are clarity, accuracy, and efficiency. First, ensure the data set is complete and relevant. This enables the data scientist to use the new patterns yield from the data in the relevant places. Second, ensure using appropriate graphical representation to convey the right message. Third, use efficient visualization technique, which highlights all the data points. There are some basic factors that one would need to be aware of before visualizing the data. Visual effect, coordination system, data types and scale, informative interpretation. Visual effect includes the usage of appropriate shapes, colors, and size to represent the analyzed data. The coordinate system helps to organize the data points within the provided coordinates. The data types and scale choose the type of data, such as numeric or categorical. The informative interpretation helps create visuals in an effective and easily interpretable manner using labels, title, legends, and pointers. So far, you have learned what data visualization is and how it helps interpret results with large and complex data. With the help of the Python programming language, you can perform this data visualization. You'll learn more about how to visualize data using the Python programming language in the subsequent screens. Many new Python data visualization libraries are introduced recently, such as Matplotlib, Visp, Bokeh, Seaborn, Pygel, Folium, and Networks. The Matplotlib has emerged as the main data visualization library. Let's now learn about this Matplotlib in detail. Matplotlib is a Python two-dimensional plotting library for data visualization and creating interactive graphics or plots. Using Python's Matplotlib, the data visualization of large and complex data becomes easy. There are several advantages of using Matplotlib to visualize data. They are as follows. It's a multi-platform data visualization tool built on the NumPy and SciPy framework. Therefore, it's fast and efficient. It possesses the ability to work well with many operating systems and graphic backends. It possesses high-quality graphics and plots to print and view for a range of graphs, such as histograms, bar charts, pie charts, scatter plots, and heat maps. With Jupyter Notebook integration, The developers have been freed to spend their time implementing features rather than struggling with cross-platform compatibility. It has large community support and cross-platform support as it is an open-source tool. It has full control over graph or plot styles, such as line properties, fonts, and axis properties. Let's now try to understand a plot. A plot is a graphical representation of data, which shows relationship between two variables or the distribution of data. Look at the example shown on the screen. This is a two-dimensional line plot of the random numbers on the y-axis and the range on the x-axis. The background of the plot is called grid. The text first plot denotes the title of the plot, and text line 1 denotes the legend. You can create a plot using 4 simple steps. Import the required libraries, define or import the required dataset, set the plot parameters, display the created plot. Let's consider the same example plot used earlier. Follow the steps below to obtain this plot. The first step is to import the required libraries. Here we have imported NumPy and PyPlot and style from Matplotlib. NumPy is used to generate the random numbers, and PyPlot, which is built in Python library, is used to plot numbers, and style class is used for setting the grid style. Matplotlib inline is required to display the plot within Jupyter Notebook. The second step is to define or import the required dataset. Here we have defined the dataset random number using NumPy random method. Note that the range is 10. We have used the print method to view the created random numbers. The third step is to set the plot parameters. In this step, we set the style of the plot, labels of the coordinates, title of the plot, the legend, and the line width. In this example, we have used ggplot as the plot style. The plot method is used to plot the graph against the random numbers. In the plot method, the word G denotes the plot line color as green. Label denotes the legend label, and it's named as line 1. Also, the line width is set to 2. Note that we have labeled the x-axis as range and the y-axis as labels, and set the title as first plot. The last step is to display the created plot. Use the legend method to plot the graph based on the set conditions, and the show method to display the created plot.